Right, I'm going to make a video for worksheet 86, number 3, just to buy us more time when we talk about other stuff. But this is continuing what we talked about in class on Thursday on Zoom. So another FRQ, let f of x be given by this function, and there's a line 18 minus 3x where L is tangent to the graph. R is the region bounded by the graph, and S is the region bounded by the graph and the line L and the x-axis as shown. So what we want to do, and I've drawn on my graph already, but I'll show you what that means, is I want to show that L is tangent to the graph of f of x at the point x equals 3. So we are given that this part right here is 3, right? Because we're told they're tangent at 3. So if we have that f of x equals 4x squared minus x to the third, we know that f prime of x equals 8x minus 3x squared. So we want to know when is this slope equal to the slope of this line? When does, what we're going to have, we know that the slope at this point is going to be the same for both the function and this line. Well, we know that the line is represented by y equals 18 minus 3x, and we can look at that. It's in the form of y equals mx plus b. We know that the slope is negative 3. So what we're going to do is we're going to take this derivative and set it equal to negative 3. Now the reason this is a calculator problem is because we're going to have to go into our calculator and type right here that 8x minus 3x squared equals negative 3, comma x, and we see that those two are going to equal each other at either when x is negative 1/3 or when x is 3. All right, so what we're going to do is we're going to come back here, and it's going to work when x equals negative 1/3 or x equals 3. Well, if we look at our function, right, if this line continues eventually to touch up here, and it'll be negative 1/3, but I only care about the 3. Okay, so I only care that it happens at 3, which I didn't even need to do that because they told me when it happens at 3. So now I want to find out what is this point right here, and that point is 3, 9. How did I figure out that it's 3, 9? Well, I took the 3. Oh no, I needed the 3 right here. There's too many 3's in this problem. I needed to find that it happened at 3, which they told me, right? So I guess I didn't need to do that, but there's another reason. There's another reason why it proves that it's 3. But if I take y equals 18 minus 3 and plug in the 3, we're going to get that y equals 9. So that's the way I know that that point is 3, 9. All right? So show that line is tangent to the graph of f of x at the point 3. Oh, well, we did that by showing that f of x, why can't you see this? Sorry. F of x touches line L at 3, 9. Since, L is y equals 18 minus 3 times 3, y equals 9, and let's verify that it touches at 9 by plugging 3 into the 4x squared minus x to the third. So we're going to get 4 times 3 squared minus 3 to the third, so we're going to get 9 times 4, 36 minus 27 equals 9. So we can verify that f of x goes through the point 3, 9, right? And this touches 3, 9. All right, so that's all we need to do to verify it. So now let's talk about the area of S, okay? The area of S, okay? So I know that this is 3, but I need to figure out what this is right here, because from here to here, when I calculate this area, right, from 3 to whatever this number is, I'm going to have a top equation minus a bottom equation. But once I get past this point right here, past this point, it's just this top equation minus the 0. So we have to figure out what this point is here. And to do that, we need to know when is f of x, this function here, when is y equal to 0? So let's figure out when that y value is 0. So we're going to go like this, part B. When is f of x equal to 0? So we're going to go like this. We're going to go 4x squared minus x to the third equals 0. Now factor out an x squared, and we get 4 minus x equals 0. So it's when it's 0 and 4 is going to make that a true statement. Well, we can see 0, and then this must be 4. So I'm going to have two integrals, one from 3 to 4, and one from 4 to whatever this point is here. So now I need this point. This point is on my line L. So when is L equal to 0? Okay. When is L equal to 0? So we're going to go 0 equals 18 minus 3x, or 3x equals 18, so x equals 6. So we know that this is at 6, right? So we're going to do an integral from 3 to 4, and then one from 4 to 6. So let's set that up. We're going to go from 3 to 4 is my top equation, which is line L, 18 minus 3x, and my minus my bottom equation, which is 4x squared minus x to the third dx. And we're going to plug that into the, plus, we're going to go from 4 to 6 of just L. L is the only thing, 18 minus 3x dx. And we're going to type everything into our calculator, and we're going to get 9.833. Right? So you can check that on your calculator, make sure I did it right. And then for part C says, find the volume of the solid generated when R goes around the x-axis. So now I only care about this one function right here. I don't have to use L at all. I just want to go from 0 to 4, because R goes all the way to, I just care about this function right here. I don't need the L, just this line right here. So I'm going to go from 0 to 4. And here we are. We're going to go from 0 to 4. I'm looking for volume. Is this a disc or a washer? Well, since I am going around the x-axis, and remember we talked about there's no space between the x-axis and my shaded area R. It's not really shaded, but you know. So then it must be a disc. So I just need one radius, and it's the R, 4x, or the f of x minus x to the third dx. And that equals 64 thirds pi, or 67.0206. So this is what you would type into your calculator and see if you get that. So check out worksheet 86 number 3 and see if you are getting the same thing. All right?